Assalamualaikum, we are from Group Mhh. Today we will present our project regarding microservice and university, which is room and venue booking. Unispace is a room and venue booking microservice developed by Mhh Solution. It serves as a centralized digital platform that helps universities manage room booking more efficiently by addressing issues such as double booking, slow approval process, and lack of real-time visibility. Built using microservice architecture, Unispace is scalable, flexible, and easy to integrate with existing university systems. Beyond improving campus operation, Unispace also has strong potential for future expansion and commercialization. Next, Mhh Solution is a university-based technopreneurship startup established to design innovative digital solutions for higher education institutions. Our company focuses on applying modern microservice architecture to solve real operational challenges within university. The team consists of 6 members: Mihaz as project manager, Muhammad Ifzan as business analyst, Harid Fahmi as system architect, Muhammad Zawadi Shafiq as back-end service designer, Joseph Adin as UI UX and prototype designer, and lastly, Johannes Eric as documentation lead. This collaborative structure ensures both technical quality and business feasibility. Next is problem statement. Many universities still rely on fragmented or manual room booking systems that are inefficient and time-consuming. This process often lacks real-time availability information, leading to double booking, scheduling conflicts, and long approval delay. As a result, students, lecturers, and clubs experience frustration, while administrative staff face high workload and frequent coordination issues. This clearly highlights the need for a centralized, automated, and reliable room and venue booking solution.
Next, I will explain our customer segment and the value proposition of our room and venue booking microservice. Our room and venue booking microservice is designed to support key users within the university. Students need a quick and reliable way to book rooms for study sessions and activities. So our system allows them to check availability and make booking instantly. At the same time, lecturers use the platform to find available room for classes and consultations without worrying about schedule clashes. As booking demand increase, administrative staff benefit from automated approval and centralized management, which reduce manual works and booking conflicts. This also supports university clubs who can book venue fairly and transparently for meetings and events. To support all these users, our microservice provide real-time availability, automated validation, and conflict prevention. The user-friendly interface and notification improve convenience, while centralized data reduce error and dispute.
My name is Harid Fahmi, and I will continue explaining about 4 key features of our proposed project. The first one is real-time conflict resolution. The core innovation is an automated validation engine. By streamlining reservations and offering live availability updates, the system greatly minimizes the chance of duplicate bookings, scheduling issues, and manual input mistakes. This ensures accurate record keeping and smooth operations without requiring human oversight. The second one is role-based access control. To ensure security, the system distinguishes between user privileges. This feature is a crucial part to monitor and maintain the booking system between users and admins. The next one is dynamic scalability. During high traffic periods like exam week, the system automatically allocates more computing power. Microservices significantly outperform monolithic architecture in handling such variable loads without crashing. And the last one is API-first integration. Unlike rigid legacy system, room or venue booking microservice is designed to integrate with the university's existing student information system. Noting that API-driven microservices facilitate seamless data exchange between various services within the microservice architecture itself. Next, let me proceed with the 3 primary innovations of the room or venue booking microservice that shift from monolithic to microservice architecture. The first one is decoupled agility. Traditional university systems are often monolithic, meaning a small change to the booking feature requires a risky redeployment of the entire system. Microservices allow for fault isolation, meaning if our booking service requires maintenance, it does not disrupt other critical university operations like fee payment or course registration. Then, the tech stack flexibility. The service communicates via standard JSON or REST APIs. This allows developers to use the most efficient modern languages like Go or Node.js for the booking engine even if the rest of the university uses older legacy code. And the last one is fail-safe redundancy. In a manual system, if an admin is sick, approval stop. In a monolithic system, a bug crashes into the server. In the microservice solution, the booking function is isolated. If it fails alone, preserving the integrity of the wider digital ecosystem. Systems like eArena Unimas provide a functional digital interface. Visual analysis of the system reveal critical limitations that room or venue booking microservice is designed to overcome all these four features that being shown in this comparison table between eArena Unimas and room venue booking microservice. Let's see for the scope. Scope for eArena Unimas is limited, while room or venue booking microservice is universal. Limited means here is eArena Unimas specific to one domain, which is sports venues, while room or venue booking microservice handles sports, academic, and admin venues in one engine. For real-time validation, eArena Unimas apply basic real-time validation, which is checks calendar slots, while room or venue booking microservice apply advanced real-time validation, which cross-reference academic timetables and exam schedules to prevent clashes. Next one, the data integration. The data integration for eArena Unimas is Silhouette. Data often stays within the sport department, while room or venue booking microservice unified when API first design syncs data across student information systems, finance, and facility management. Last one is user experience. User experience for eArena Unimas is fragmented. Users only gain access to booking spot facilities apart from various facilities that exist in the university, while the seamless user experience for room or venue booking microservice system, which one system of experience for all campus needs.
Alright, for this part of the slides, I will be explaining about technology infrastructure. So the technology infrastructure is designed around the microservice pattern to achieve the project's goal of real-time conflict resolution, dynamic scalability, and integration with other existing university systems. This architecture directly addresses the university's pain points, which is double bookings, lack of real-time visibility, and poor system compatibility. So these are the overview of the slide. The design using microservice architecture then supports real-time venue availability and automated booking. It eliminates double booking and manual processing, easily integrates with existing university systems, and then scalable and suitable for SAS deployment. Okay, now we move on to microservice architecture. First one, the system is divided into 6 independent microservices. Each service communicates using REST APIs, and then fault isolation ensures the system stability. It allows individual services to be updated without downtime. And then these are the key services. The first one is API gateway, then user authentication service, then facility venue service, and for booking is reservation service. Alright, now I will be explaining the booking flow and integration. So for booking process, the user submits booking request. This is the request, and then the user will go through the authorization, which the user role verified. It goes through the RBAC, which is role-based access control, and then the system checks. This is for the conflict validation. The booking service initiates 2 parallel checks for the requested time slot. Here it will check the internal venue availability, and then for the external check, it will check the academic timetable, which is TS, and then it will after that it will go through booking confirm if no conflict. Here means it will check whether it is free or not. Then if it is free, then it will be confirmed, and then notification will be sent to the user. For this part, maybe we will be using Kafka, which I will explain later on the technology stack. And now we move on to the system integration. So for academic timetabling system, which is ATS, the purpose of it is to provide a real-time schedules to the integration service to prevent student or staff bookings from clashing with scheduled classes. And then for student information system, it validates user identity, current enrollment status, and then autofills personal data like metric number, faculty, thing like that during the booking submission. And then for facility management system, it synchronizes venue status. It's like marks a room as under maintenance or out of order. Okay, now lastly we go through the technology stack, which I will explain layer by layer. The first layer, which is backend and core logic, the proposed technology is Go or Node.js. Both is highly efficient for high throughput API for communication for booking service. Then Node.js allows for rapid development of simpler services like notification or user or authorization. And then second layer is database, which the proposed one is will be PostgreSQL for relational, and then Redis for in-memory cache. So PostgreSQL is robust for complex transactional in records. Then Redis provides extremely fast lookups for real-time availability checks. And then the third layer is inter-service communication for the notification like message broker. The proposed technology will be Kafka or RabbitMQ. It decouples services, ensuring fail-safe redundancy and that asynchronous operations like notification and it do not halt the core booking process. And then another layer is API gateway, which for this one the proposed technology will be NGX or Kong gateway. It is high performance, open source gateways capable of handling security, then rate limiting and routing all the microservices. And then the next layer is deployment or hosting. For this one, we'll be using Docker and Kubernetes. It enables the system to be containerized and scaled automatically on demand, which is crucial during peak university usage. Like for example, like during exam week registration. And then for cloud provider, which is the last layer, the proposed technology will be AWS or Azure. This will provide the necessary infrastructure for hosting and manage database services. That is all from me. Thank you.
Now, let's look at the financial estimate and projection for our proposed venue booking microservice. This section covers the expected cost for developing and deploying the system for over 12-month periods. These estimates are based on logical assumptions and industry benchmark rather than detailed financial statement. The goal is to ensure our project is feasible and financially sustainable. Funding sources and assumptions. We assume the project will be funded through internal sources such as university innovation grants, digital transformation budget, or IT development funds. No external investors are considered since the solution is intended primarily for internal use. Key assumptions include the 12-month development period, a total budget limit of 300,000, a small university-based development team, and a cloud-based SaaS-ready development deployment model. The system will be prototype level, production ready, but not enterprise scale. Next is asset identification. Our project utilized both current and proposed asset. Current asset includes the university IT infrastructure, academic and student information system, human capital, and open source software. Proposed asset consists of room, venue, booking, microservice, cloud infrastructure, APIs for integration, and user documentation and training materials. Next is estimate project costs in 12 months. Breaking out the 12 months cost is development. Firstly is development implementation, which is 100,000 ringgit, covering system design, microservice development, integration, and dashboard design. Infrastructure and operational costs, costly about 35,000, including cloud hosting, storage, and security tools, while training support and contingency costs 35,000, covering user workshop, technical support, and reserve funds. This total is 190,000 ringgit, which is well within our 300,000 budget. Next is total financial projections summary. Here's the cost breakdown by category. Firstly is development and implementation, which is cost 120,000 ringgit with a percentage of 52.6%. And infrastructure will costly about 35,000, which is about 18.4%. Personnel and support 35k with 13.2%. Testing and quality assurance will costly about 20,000 K ringgit, 20k ringgit, and with percentage of 10.5%, and contingency it will be 10,000, which is have 5.3%. The total cost of 190,000 ringgit leaves a comfortable margin for unforeseen expenses. Next is operational cost outlook for post year 1. After the first year, development costs are no longer required. The system enters a maintenance phase with significantly lower annual operating costs. Firstly, we could say cloud hosting and infrastructure is equal to 15k, while maintenance and updates is equal to 10k, technical support will be 5k, security and monitoring will be 3k, and miscellaneous, the others will be 2k. So the total annual cost will be 35,000, a reduction of approximately 81.6% compared to year 1. Next will be financial sustainability and projection summary. Over 3 years, the cumulative costs are for year 1 will be 190k, and year 2 will be reduced to 35k, and following the next year, year 3 will be the same as year 2, which will 35k. So totaling 260,000 by year 3. We expect annual tangible benefits of 230,000 from administrative savings, reduced scheduling conflicts, and better facilities utilization. The break-even point occurs in month 10 of year 1, giving a return of investment of 21.1%. There's also commercialization potential of 1.2 million over 5 years, targeting 5 universities at 50,000k per year each. These demonstrate both financial and efficiency and long-term sustainability. That's for my wrap-up for estimation.
Next, I'll be covering the business feasibility, risk analysis, and return on investment for our room and venue booking microservice. From a feasibility perspective, this project is viable across 3 key areas. First is technical feasibility. Our system is built using microservice architecture, which is widely adopted in modern cloud systems. This allows individual services such as booking, authentication, and notification to operate independently, making the system scalable and easier to maintain. Second is financial feasibility. By adopting a lean deployment strategy, we optimize the overall project cost to 190,000 ringgit, staying well below the maximum budget while still delivering full functionality. There are 2 risk analyses. One of them is operational risk, which is user adoption and integration. Second one is mitigation, which is pilot development and training. Despite being feasible, there are several risks that we have identified and addressed. One major risk is system integration, especially when connecting with existing academic and student information systems. To mitigate this, we propose a dedicated integration service and thorough testing during the development phase. Another risk is user resistance. particularly among administrative staff who are used to manual processes. This will be managed through pilot deployment, training session, and user-friendly interfaces. We also consider performance and security risks, which are addressed through load testing, role-based access control, and security audits before full deployment. Beyond internal use, this system has strong commercialization potential. This platform can be offered as a software as a service or SaaS solution, targeting universities and educational institutions facing similar booking and scheduling challenges. Due to its cloud-based and modular design, the system can be easily customized and deployed for different institutions without needing a major redevelopment. In the long term, the solution can also be expanded to support corporate venues, training centers, and shared facilities, further increasing its market potential. In terms of our business model, the primary customers are universities and large institutions. Our value proposition focuses on automating the booking process, eliminating double bookings, and improving overall operational efficiency. Revenue is generated through an annual subscription model, which provide predictable income while remaining affordable for institutions. Key cost components include cloud infrastructure, system maintenance, and technical support, all of which scale efficiently as the user base grows. Now for project milestone and ROI. The project is implemented over a 12-month phase timeline, starting from planning and development, followed by integration, pilot testing, and finally full deployment. With a total project cost of 190,000 ringgit, the system generates tangible annual benefits of approximately 230,000 ringgit through administrative time saving, reduced booking conflicts, and improved facility utilization. As a result, the project achieved a positive return on investment of 21.1% within the first year. Over time, as maintenance costs remain relatively low and adoption increases, the ROI improves significantly, reaching approximately 165.4% by the third year, making the project both financially sustainable and commercially attractive. So overall, our analysis shows that the system is not only technically feasible, but also financially viable and scalable. With this, I'll now pass the presentation to our group leader for the conclusion.